All right, guys. Hopefully you watched the Khan Academy videos about E and kind of what it means. As far as what we've used it for, it does show up in continuously compounding interest. But we're just going to do some math with it today. So E is an, I got a fancy new pen, so it writes a lot better. Is an irrational number with a value of approximately 2.71828, etc. You guys know how to read. Base E exponential functions are called natural base. That's where I put my hand. Natural base. Example, f of x equals e, the natural base, to the x power. And as you saw Sal Khan say, e to the first power is the value of e, and that is the 2.718 that he showed how you found it. Logarithmic functions with base e are called natural bases or natural logarithms. I like how we said log natural for ln. Example, f x is equal to log base e. Nobody really uses log base e. They just use ln or log natural. So this is abbreviated as, this is how we'll usually see it, the natural log of x, log natural. All right, so you get some examples. E to the x is equal to 24. You would natural log both sides. Really, it's log base e. Really, it's your log base e of e. That's a cancel move to the x power equals log base e of 24. But the easier way of writing that is to natural log of e to the x cancels equals natural log of 24. So off to the side, x equals natural log of 24. As he said, you probably have to put 24 log natural in your phone if that's what you're using. And just so if you are putting it into your phone right now and you're trying to figure out if your number is coming out correctly, that value for the natural log of 24 is equal to about 3.18. So I'm just going to do that decimal value right there so that you can get a hang of putting it into your phone or whatever you're using if it's not a graphing calculator. So if you don't get 3.18, put it in a different way until you do. All right, number two, we are to write it in, oops, natural log of e to the ninth is equal to natural log of x. So natural log and e cancel. 9 is equal to the natural log of whatever x is. So we're just rewriting these equations in logarithmic form. We're not doing any calculations here. All right, number three, natural log both sides. Natural log of e to the x plus 5 is equal to the natural log of 72. Now, when you're doing this, when you cancel natural log of e, x plus 5 is equal to the natural log of 72, you have to get that result of the natural log of 72 first and then subtract the 5. Do not do subtract 5 from both sides and think incorrectly that you're doing the natural log of 67. That is not what's happening. You're taking the natural log of 72 and then subtracting 5 from that result. That's why I put parentheses around the 72, then a minus 5. Okay, so that value, just in case you're trying it, even though we're only supposed to rewrite this, the natural log of 72, close my parentheses, then subtract 5, is equal to negative 0.72. Okay, write these in exponential forms. So exponentials are inverses of logarithms. So since this is a logarithm, the inverse of that is exponentiating with an e. So that looks like e to the natural log of x cancels e this side. So that means that x is equal to e to the 58th power. On this side, exponentiate with an e, exponentiate with an e. 6 is equal to e to the x power. Over here, e to the natural log of x minus 9 equals e to the 32nd power. So x minus 9 is equal to e to the 32nd. We're only rewriting these. E to the 32nd, then minus 9. Plus 9, sorry, plus 9. Because we add 9 to both sides. I'm trying to get this under 15 minutes, and I'm already at 7. All right, now the cool stuff, the review stuff. Condense. We're going to condense and expand. So this goes all the way back to the beginning of this unit before spring break when we were condensing and expanding logarithms. Addition means multiplication, so that is simply the natural log of 48. We're just rewriting this. The natural log of 63 minus 2 times natural log of 3 means division. Remember, when we're condensing, we have one log statement. So that is 63. Minus means divide. Coefficient of 2 becomes the exponent on 3. So that is 3 to the 2nd power. Now, because you can tell these numbers clean up, that's 63 over 9, which is just 7. I want your final answer, if you can simplify it, to go all the way down and just say that the simplified value of that, why do I keep putting equals? It's natural log of 7. That is as simple as you can get. All right, so this one. We've got natural log of 1/3 natural log of 64 plus 2 natural log of x. We're condensing, so we want one natural log statement. Plus means times. So that is 64 to the 1/3 power times x to the 2nd power. And that simplifies down to natural log, cube root of 64 is 4 times x squared. And that is all that you have to do when you're condensing. Expanding is pulling it apart, doing the reverse of what we just did, and writing out a lot more. So natural log of 5x is natural log of 5 times x. So natural log of 5 times means plus natural log of x. When you're expanding, each entity needs a logarithm. Let's see. You guys might not do this way, but I'm going to say that that is equal to the natural log of a to the 6th over b to the 2nd. If you want to put a 2 out in front of everything and have a bunch of parentheses, that's fine. It's equivalent, and that's what matters, but I'm not going to do it that way. So natural log of 9 to the 6th, a to the 6th power over b to the 2nd power, will first expand that down to a to the 6th minus natural log of b to the 2nd, and then we'll take those exponents and make coefficients out of them. 6 natural log of a minus 2 natural log b. Parentheses are there just to separate. Okay, so the natural log of the cube root m squared n. This may take a little bit of space. You know me, I like to show my work. Natural log of m squared n. Cube root is the same as to the 1/3 power. Okay, then from there, I'm going to distribute. You can take that 1/3 and do what I just said. The equivalent version of number 11 would be 2 parentheses natural log. What am I doing? Oh, 3 natural log of a minus natural log of b. So on this one, I'll write the equivalent version. I'm going to say that this is natural log of m to the 2/3 n to the 1/3 and use those coefficients and say that that is equal to, it's times right there. So that is 2/3 natural log of m plus 1/3 natural log of n. If you were to take that and do it the other way, you would take this 1/3. I would still do this here, but you could say 1/3 out in front of everything, parentheses, 2 natural log of m plus natural log of n. Oh, next page, solve. I'm going to stop this video because it's going to get cut off, and then I'll make a separate video for this page. So to be continued on logarithm video number 2.